After the sprint planning meeting, the team is ready to start. And in Scrum, we often use a visual board we put the product backlog on the board, and any tasks that we've broken down from that backlog are on the board, and they're in a column of things to be done. And the team meets in front of the board, and they talk about, okay, how much did we get done yesterday? Each person speaks, what have I done to help the team move forward? And what do I think today, where can I make my best contribution? And are there any issues, either for myself or the team, that I see that are blocking progress that we need to talk about? So based on that conversation, people will pull things from the board, move them into a status of being worked on, and then people will do their work. Often people will try to work together on the top priority backlog items on the board. It turns out that in a sprint, usually the constraining factor is how much time is it going to take to get something done and tested at the feature level. At the end of the sprint, we want a user to be able to look at the software and actually use any features worked on. So testing is a real constraint. So the team needs to work the top of that board, try to create something that can be tested quickly, and then pass a steady stream of testable functional code to whoever's doing the testing. They may have professional testers, the team may be testing themselves, but nobody tests their own code. There's always someone else testing it. Building a steady stream of testing all through the sprint. On the last day of the sprint, they're going to have the sprint review and look at that code. Now, in the sprint cycle, it turns out that having good engineering practice is really important. So, for example, at OpenView, our standard are that the teams really need to be doing continuous integration so that they can build all the software every day, multiple times a day. They need to have automated testing in the build process so that they can do some automated testing as they're building. And the teams need to either be doing pair programming so that they're looking at each other's code as they're working, or they need to be doing code reviews if they're doing independently. Getting these basic engineering practices right is critical. And at the same time, as problems are identified during the sprint, those problems need to be removed. Some of them the team can work on, others may require help from management or other people. The Scrum Master and the Daily Scrum is responsible for making sure that there's a list of what we call impediments and that they're being systematically removed during the Scrum. So that's a simple idea of how the Scrum works. It's based on self-organization, so people are figuring out how they will work during the Scrum dynamically in real time. Nobody's telling them what to do. They're pulling from that backlog, and they're working on that backlog, trying to get it all done by the end of the sprint.